Welcome for mathematics lesson. We are going to study linear motion, whereby we will consider velocity time graphs. We know that from velocity time graphs we can calculate several things like distance covered, acceleration, deceleration, among other quantities. Therefore, we shall consider a set question here. Make sure you subscribe to this channel as we continue. We are told that a particle from rest attains a velocity of 10 meters per second. 2 seconds, after 2 seconds, it then moves with 10 meters per second velocity for 4 seconds. It finally decelerates uniformly and comes to rest after 6 seconds. Draw a velocity time graph for the motion. So what we do here, we're going to sketch this motion. We're not going to draw the actual diagram. We will just sketch because we don't have a graph whereby we can get a scale diagram. Therefore, to sketch this motion, velocity time graph, we will have velocity and have time on this side, such that this is time, which is in seconds, and this one is velocity, which is in meters per second. Therefore, we are told a particle moves from rest. Rest is 0 and attains 10 meters per second after 2 seconds. So within the first 2 seconds, we will have a velocity of 10 meters within the first 2 seconds, such that we can have a uniform acceleration. So that is within the first 2 seconds, we have 10 meters per second. We are told it then moves with the 10 meters per second velocity for 4 seconds. So within other 4 seconds, this will take us to the 6th seconds. The particle will be moving uniformly with that velocity of 10. Then now, after moving with 10 meters per second for 4 seconds, it decelerates uniformly and comes to rest within 6 seconds. So from 6th second, within other 6 seconds, this will take us to 12th second, and this particle will have come to rest. Getting back to rest means getting back to 0. So this is the sketch of the motion of this particle, velocity time graph. Then we are told from the graph, we find the acceleration during the first 2 seconds. So within the first 2 seconds, we can consider acceleration. We know acceleration is given by final velocity minus initial velocity out of time, because acceleration is the change in velocity with the time. So the final velocity of 10 from 0 is achieved within 2 seconds, and this is going to give us 5 meters per second squared, because it is acceleration. So after getting acceleration, we are told to find the uniform deceleration during the last 6 seconds. Therefore, to get deceleration, we know that deceleration is negative acceleration. So we use the formulae for acceleration, because acceleration is given by v minus u out of time, and this is going to be given by a final velocity of 0 from 10 within 6 seconds. So this is going to give us negative 10 out of 6. This will give us negative 1.667, because it is 6 recurring meters per second squared. Since acceleration is being negative, then we will call it deceleration, and we give it the absolute value of 1.667 meters per second. The velocity is decreasing with time. That is why acceleration is becoming negative. Then now finally we are told to find the total distance covered by the particle. For us to get total distance in part 3, getting total distance means getting the area under the graph. The shape of the graph is trapezium, and we will consider these two parallel sides, whereby the units within the lower parallel side is 12. Then we have from 2 to 6, we say this is within 4. Therefore, we have 4 and 12. And the vertical distance between the two parallel sides is 10, because it is from 0 to the highest velocity, which is 10. Therefore, here we will have 10. as the unit there. Therefore, for us to get distance covered, we'll say distance equals to area under the graph, and because it is trapezoidal in nature, we'll use half the sum of the two parallel sides, whereby we have 12 and the other one 4, multiplied by the distance or the distance separating the two parallel lines. So we will have 16 divided by 2, we get 8 times 10. This will give us 80. Therefore, 80 meters is the distance covered by this particle before getting back to rest. Thank you for following. Subscribe to this channel and share the link.